Hello, my name is Bim. This recording is for my YouTube channel Programming Interviews Collection. And today in this video, what we're going to discuss is the video supplement of one of the problems. But I would like to give some kind of context why kind of this particular recording, because I already have programming videos there. So the main reason why we are recording this is particularly because in the interview process, the major thing that these programming interviewers are looking for is how the potential employee, the potential software engineer, comes up with a solution, and also along the way how the interviewee actually drives himself or herself to the right direction. So in that context, if we look at materials in the internet, what we also see is there are a lot of programming blocks and ready-made programs available in the internet. If you do a Google search, we should be able to get solution for many different types of problems. So I think there is really no shortage of this kind of solution. But if we try to find information about mental process, that is how a programmer actually arrived to that solution, it is not so easy to find proper material. So what I thought was maybe I discuss how we try to come up with the solution, the mental process mainly, because otherwise coding is already there in the channel. We're going to supplement this with how we actually arrive to the solution, because in the interview process, if we have a lot of practice, we might end up with the right solution very quickly, and the interviewer might be impressed. If we do not have right solution, if we have not practiced before, then probably it will depend on how we think, how we communicate, and then how we take a direction when we have a problem to solve. So for this, let's take the problem of I have a problem ready here, that is given an array of integers, return indices of two numbers such that they add up to a specific target. So we'll use the board. So please don't worry if you don't see me kind of a partial view of myself. The major focus is the board, so at least you see what is written in the board, and you also hear the voice. So if let's say the given array is, this is the array, let's say, well, this doesn't rate. Let's say this is the array 10, 20, 35, 40. Okay, this is the given array, and then that's not visible. Let me write that one more time over here. 10, 20, 35, 40. Okay, see, that is visible. Yeah, this one over here, and then the target, let's say it is 30. Target is equal to 30, right? So here what we are trying to do is we walk through this array 10, 20, 30 array elements in case of board from left to right, and then see which two of them actually add up to the result. Okay, and then we return the index. That's our problem statement. So for this one, what we do is actually we try to come up with a solution. So how do you do that? So typically in the programming course, the first programming course, what we do is we iterate through any structure. This is the array. It can be treated as array in pretty much every high-level programming language, because most of the high-level programming language, they have array structure available. Even if they don't, probably we can create our own if they have other similar primitive structure available. But it's very likely that many high-level programming languages like Java, C, Python, all of these languages, they have one or the other form of the array. So that's why we will just try to kind of treat this structure, what we are seeing, is an array. Array is in programming languages. So how do we do it? So we have now obviously it's a computer language. If it's a mathematics, and if you're doing it through our mind, probably it's not that difficult, this particular array. I can just look up the elements and then try to add, and then see which one results 30, right? First element take and then combine, check with other, and then take the second element, combine with remaining, and I have vision, very good vision, meaning, we human being, we can move forward and backward as we want. We are much more sophisticated than at least to present as computers. So that's a lot easier for us. But computer, it's stored in a particular way. It has to be traversed in a particular way. All that computation power, the memory, the processing, all those things. That's important. So now, having said that, there are certain things in computers, because computers were designed by human being. So it also operates to some extent how we operate, or more accurately, probably I could say that it was designed to mimic at least some of the human behavior of computation. So now, what's the typical approach that we do in a let's say in a first programming language course? Probably that's where many programming candidates they start. We take the first element, compare it with the rest of the element, and then we take the second element, and then not compare, but just add two elements. First element add with second and see whether it's 30. First element add with the third element and see if it's 30, and so on. And similarly we do the second element and check with the first, check with the third, and so on. We do that, and then if we see the sum matching to 30, then we return that. So typically what we would do is, if there is an array, let's say this is an array that has let's say that has these elements, then what we do for, and then we'll do and I is equal to 0. This refers to some programming language. Let's say something like Java. I less than or equal to a dot size or length, array length, and plus plus I or I plus 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 plus, both of them, that will work. And what do you do if AI, probably we need one more loop here, because we need to check that element, the current element, with the rest of the element, and then that current element also has to actually move across. It should move, and that's its boundary, and then the element with which it will be added also has a boundary. It will be not the all other elements except the current element. So in that case, we need like two loops, because we need to traverse through the array, right? So this is how we traverse through the array in programming languages. So I need another loop for j is equal to, well, j, where should we start? So probably should we start at let's say if I'm doing the first element in the outer loop, then it should probably start from the second element. That be j is equal to I plus 1, and then j also should not cross the length, because in programming languages mostly the indices start with 0 and they go to n minus 1. Okay, that's why we have this less than length. I could also less than or equal to length if I start with one index here. So j is less than a dot length and j plus plus. Okay, and then I start another loop inside loop within loop. So now what do? If I do this, if a I plus a j is equal to target, then I could say return, maybe it's an integer array, and you can say you can actually return I and j, right? And then the rest of the things. But there is some problem. The very first problem with this is it is, see, outer loop, this will be of order of n, that's time complexity, and the inner loop, that is also order of n. So if you see this 2, your solution is going to be order of n squared. And then if that is the case, now we have 1, 2, 3, 4 elements. But if we have billions of elements, then you know your time complexity is going to be order of n squared, and that can help the computer or the solution can become very slow. So for that reason, in interviews, generally this solution, unless there is no way to find a better solution, this type of solution, at least for this problem, is not considered to be a good solution. If we just leave this solution and then say that okay, that's the solution that I can provide, then it's very likely that we may not get the job. So and there is another problem here. This loop actually does not completely cover the elements. So if it's the first element, I'll be adding with the second element, right? Second, third, and so on. And next time I reach to the second element, then I'll be adding the second element with the remaining, right? And then next time I do the third element, third element here, and then I do the remaining, right? So it may not compare with the previous elements, but it does guarantee that each element is actually combined with other element. Let's just try to check which how 40 and 35 will be actually combined together. Okay, so that one, let's start with 35. So if 35 is going to be combined, that one, so that works. How 20 and 35, it comes through the loop of 20. How 10 and 40, that comes through the loop, first loop. In I is equal to 0, you come with the for this element in AI, and then in j, when it iterates, then at some point it will reach there. So it looks like it does actually cover the element, but obviously we see the main problem here. The solution is actually order of n squared, which is not considered to be the best solution. Okay, so for that reason we'll have to actually write a new solution, and we do have a new solution. Again, we'll have to talk in terms of computer programming languages, because that's what we'll be using in order to implement it. So many programming languages, they have a structure where we can get we can store information. This is structure. Basically, you have a key and then value pair. You have a structure where you can have you can store a key value pair, right? So if you supply a key, you can get value, and if you supply value, you'll get the key back. Okay, so this structure, actually, in order to look up, it only takes just one time. If you know the key or the value, and if the keys and values are not duplicate, then it only takes order of 1, which is a very, very efficient solution. Okay, that's just for the lookup. Okay, of course we'll have to check the entire the time complexities, space complexity of the entire program, but as far as this lookup is concerned, this probably is the most efficient data structure available in programming languages that are available today. Okay, in future probably some other when new programming languages show up, they might come up with a more efficient structure also, who knows, or if quantum computer becomes more kind of widely available and also cheap, at that time also I think we'll have a different type of computation, but till that time we'll have to still do with our conventional traditional computers, the digital computers, which are still very good computing machines. So one solution that one efficient solution that we can come up with is using the this HashMap data structure. Many programming languages they have. Python has, Java has, Scala has. So now what we will do is we'll try to come up with sort of algorithm, right? Since this video is more on the mental process than on the code, because code we can also get in the internet, but how do we do it? So we'll just try to come up with this mental process